Hi students, one more example we can see in push-down automata.
Obtain a PDE to accept the language L is equal to W such that W belongs to A or B for any
Number of times.
and the condition is this
Hash of A indicates number of A. Right, a hash of A indicates number of A. Hash of A indicates
number of A. Number of A of W should be equal to number of B of W.
right. Number of A of W should be equal to number of B of W. So what is the difference between this example and the previous example? Right. Previous example is A and B. And here also number of A and B should be same. I should have equal number of A and B. But the difference between this and the current question is, here I have to follow the ordering. First I should have A and then followed by B. But here condition is only on count. Right? I should have equal number of A and B. Right? This is a valid string for this language. This is a valid string for this language. Right? Even this is a valid string. This is a valid string. Right? It doesn't see the order of A and B. Right? How is arranged. It doesn't look after that. It sees only the count. Count of A should be equal to count of B. That is the only thing it considers. Right? So here in this question, what I will do is like, right? When whichever is your first symbol, right? You'll get an input string, right? Whichever is your first symbol, that I'll push into my stack. The other symbol, when you see the other symbol, I'll start copying and I'll check whether I have equal number of A and B. Right? And since this string is a valid string for this language, till now we have seen two examples. In both the examples, first half I'll push and I'll keep a separate state for push, and when I start popping I'll make a state change, then I'll pop. Till now we have seen like that. Both examples it was like that. But here, suppose here my first symbol is A, right? So whenever I see A, I have to push. Right here it is push. Next when I see a B, I have to pop. Again when I see a I have to push. And when I see a B, I have to pop. I have to pop. Suppose if you make a state change for popping, right? Here for push, I'll be in Q0. And when you see this B and you want to pop, if you make a state change, again for push, you have to come to this Q0. Right? So you cannot come back to the state. In push-down automata, you cannot come back to this Q0 state again. Right? So again here it is push. Right? So you want to be in Q0. Again it is pop. You have to make a state change. Since you cannot come back to your state, right? For pop operation, I will not make a state change in this example. That's what in the beginning. While giving the introduction to push-down automata, I told pop, satisfying the condition, right? I have to pop, right? Satisfying the condition, I have to pop, and I have to decide whether I should make a state change for pop or not. In the previous two examples, if you make a state change, it is fine, it works, not a problem. But here, right? Since your push and pop operation comes alternatively, right, you cannot make a state change for pop operation. So both push and pop I do with Q0 state, and I make a state change when I reach my end state. When I reach my final state at the end, I make a state change and I continue. But here both the operations I do with the same state. So we'll start. It's suppose if your first symbol is delta of Q naught. If your first symbol is A, stack is empty, what you have to do? You have to push A into stack. Now, what is your current state? Q naught. And what is your stack top? It is A. Right? And the next symbol, it can be either A or B. I don't know about my second symbol. If it is A, I will be pushing. If it is B, I have to pop. Right? If it is A, what I told, whichever is your first symbol, push the first symbol into the stack. When you find the other symbol, you have to start popping. Here my first symbol I have assumed as A. So all my A's, whenever I see the input symbol as A, I will be pushing that input symbol into my stack. Right? When I find B, I will start popping. This is one case. What would be the other case? If my first symbol is B, how do I know this first symbol is B? Stack is empty. If my first symbol is B, I push B into my stack. Whenever I see A, I'll start popping. So Q naught, B, Z naught. Hope it is clear. Here I am assuming first symbol is A. Here I am assuming first symbol as B. Whichever is your first symbol, you push into your stack. The other symbol, you have to pop. Right? So here I have pushed A into my stack. So stack top will be A. Input symbol, it can be either A or I can have B. Right? So if your input symbol is A, you will push. If your input symbol is B, you will pop. In this case, my first symbol I am assuming as B. So whenever you see B, you will push. Whenever you see A, I pop. Right? First symbol is B. So my stack top is B. Correct? Here my input symbol, it can be either A or B. Either A or it can be B. But stack top remains B. Since my first symbol is B, I have pushed. So whenever you see the input symbol as B, you have to push. If your input symbol is A, you have to pop. Right? Now what is the condition for final state? You are in state Q naught. When your input symbol is empty and stack is empty, right, you are reaching your final state. When you reach your final state, make the state change and you can stop. How will you draw your transition diagrams? Q naught. It is A Z naught. A Z naught. Next is A comma A. Next is B comma A, BA. Is it visible? Yes. B comma Z naught, B Z naught. Here. Next it is A comma, because Q naught, so it will be self loop. A comma B, it is epsilon. Did I make a mistake here? Yeah. It is B comma A, it is epsilon, right? Next B comma B, BB. Q1 is your final state. Here epsilon comma Z naught, Z naught. Right? Hope you understood and you got the difference between this example and the previous example very clearly. Thank you.